Before we write our programs,
okay, so like I said, we're talking about the grammar of graphics in data visualization.
Three dots button
and we said
corner of the files
the
window.
grammar of graphics have three basic components. Number one is data, number two is mapping, number three is geometry. The data tells R what data set we're working on. The mapping tells R to design the canvas or the coordinate space on which our object, which is the graph, will be. And then the geometry is now telling R what specific type of object do we want. Is it a bar chart? Is it a histogram? Is it a box plot? A density plot? Whatever thing it is. Those are those three basic components. Now, going to the code.
Click on R script. You can also use
now this is the code. Now the package
script
that we use to deliver this presentation, or sorry, this grammar of graphics in R is called ggplot2. That's the package. Fortunately for us, since we're working in the tidyverse environment, ggplot2 is also a part of the tidyverse group of packages. So once you've installed tidyverse package in your system, it comes along with ggplot, so you don't have to reinstall ggplot on your system. Once you have tidyverse, you also have ggplot. So now this is the coding, the coding pattern for graphics.
When you run
I just said we're working on the BOD data set, which is one of the data sets that you have access to once you're working in the tidyverse environment in R. The BOD data set is this.
The print statement is
it has two variables, which is time and demand, and it has 6 observations from 1 to 6. So this is time, and this is the demand with respect to the time. So we want to plot these variables.
In this case, it is 1.
Using our grammar of graphics components in R.
Let us first
now
save our work. That is the R
in the earlier talk we had mentioned that when you're plotting 2 numerical variables,
in this case
the graphics for it is scatter plot. When you're plotting 2 numerical variables, use a scatter plot. So that's what we're going to do here.
For our script.
So the first thing is you write ggplot, and then you now do those 3. If you look at this, these are those 3 components I told you about. This is data,
but using
this is mapping,
more convenient way of writing,
and this is the geometry
and executing them.
Those are the 3 components we just explained.
In the video lectures,
the data,
in this video,
the mapping,
you will learn how to perform basic
and the geometry
in R.
You can appreciate that, right?
Let us start by
Good.
writing R script
so
to add
the data, like I said, you tell R what data set you want to work on. So data equal to BOD,
we will use X,
which is our data set,
character, followed by
and then
and
press comma.
The symbol less than
you can continue typing on this same line, but just to make it neater, we press enter and go to the next line.
Side by side.
So the next thing after data is mapping,
receiving the value.
and mapping works with a function we call AES, or aesthetics. So mapping equal to aesthetics, then we open up our bracket.
So here, X
in the mapping, we tell R what we want to have on our x-axis, what we want on our y-axis. So usually on the x-axis is the independent variable, and on the y-axis is the dependent variable.
So we will have
so
X plus Y, where plus
from this data set, as time is increasing, demand is also increasing, which means demand is a function of time. Sorry.
We will now display the results.
So we tell our x-axis x equal to time, comma, we can continue typing on this line, but just to make it easier and neater, we go to the next line and say y equal to demand.
The first line is
so we've told R that time should be on the x-axis, demand should be on the y-axis. You followed up to this level, right?
Same way, the second line is executed.
Very good.
And the variable
so
y is
we now close the bracket for this.
Y is storing value 4.
We have to move to the next step, which is the geometry. So the data and the mapping are within the ggplot brackets.
The
After
next
we've done
statement
that, the
will
next
display the
geometry,
result
we'll
in
have to do that
console
on
window.
another
That is
bracket.
the
So we
result
close the
22,
bracket here,
which is the value stored
and
in
then we
variable
put
Z.
plus sign
We will
to
execute the
tell
next statement,
R
which
that
also will print the
we
value
are
stored
piping
in
whatever
variable
we've
Z.
said into
Do
the next
observe
line.
that we cannot
You know, if
just
it
use
was
the
in
run icon to
tidyverse, we would
execute
have
the
used
program.
the
The
pipe
cursor should be
operator
on the line that
where
needs
we
to be
have this plus
executed.
sign.
Once the statement is
If it was in
executed,
tidyverse.
the cursor
But for
automatically
ggplot,
moves
it's
to the
plus
next
sign you
line of
use,
the
not
code.
pipe
The
operator.
advantage of using
So we
run
write
is that
plus,
it makes debugging
and then
and troubleshooting
we now
easier.
select
Since
what
each
type
statement
of
is
geometry we want
executed
to
at a time.
want R to
Instead
plot
of
for us.
assigning values to the variables
We
and
want,
then computing
like I
the
said, for
expression,
two
we
numerical
can directly
variables, it
perform
is scatter
18
plot.
plus 4.
And a scatter plot
When we
in
place
R
the
is a
cursor
combination
on
of
this line
point
and
and
then
line.
execute, we get the same
So
result.
geom
The other
underscore point,
mathematical operators that
all
can be used
the
are as follows.
graphical representation
We
begin
can
with
use
geom. So if it's a
subtraction,
bar chart,
that is
you will see
18
geom underscore
minus
bar.
4
If it's a
will
histogram,
give
you
us
see
the result
geom
as
underscore
14.
hist. So just
In the
geom
same
comes
way,
before
we can have
all of those
18
this. So
multiplied by 4.
geom underscore
We have the
point,
result as
you know,
72.
initially we didn't have this
We
size
can
3.
also perform division operation.
So it was just
That
geom
is 10
underscore
divided by 2,
point that we
which
had.
gives the result as 5.
So let's assume
We can
I
also
remove
have
this
floating
from
point numbers
here.
in the expressions. For example, 4.5 divided by 2
I remove this
will
plus
give
sign,
the result as
and I just click
2.25.
Control Enter at this stage.
In our programming language, we also
You can
have
see in the
exponential
canvas
operator. That is, we
here
can
in this
have
plot
two
session
exponential.
here. Let me take
3.
this away so we can
The
see.
exponential operator.
You can
has
see
two
here it has
consecutive
plotted
aspects.
time
The result of
against
2
demand,
exponential 3
time on the
is 8.
x-axis and demand on
We
the
can also use
y-axis,
caret symbol
and you can
as
see
an
the different
exponential
points,
operator. For example,
the different coordinates
caret
of
3
time
will
against
give the
demand
same
on
result
this.
as 8. We can
Good.
also perform
So,
exponential
but
on
a
floating
scatter
point
plot
number,
also
that
has
is
lines. So
3.5.
we want to
Exponential
we want to add
will
that
give the
layer.
result as
So I put
12.25.
plus,
In the
enter,
same way, suppose
then
if we have to find the
geom
square root of a number,
underscore
for example,
line.
in this case, let us find square root
And then
of 9.
Control
So we will have
Enter.
9 exponential.
So you can see it has added lines to join those
This will give
different
us the
points that
result
was
as
plotted.
3. We can also
You're following
use
up
the
to this
expression
point,
9
right?
exponential operator and then 0.5.
Exactly. So now
This will also
this
give us the
plot
same result.
doesn't
That
look
is 3.
very
Let us look
attractive.
at what happens
So
when
I
we
want to make
use
it
9
to look a bit.
exponential
I can
1
do
divided
this
by 2.
presentation on my report, but I
We
just
get the
want
result as
anyone that is
4.5,
reading it
not
to
3.
like feel
This
it
is
looks
because
a bit more
the
beautiful.
exponential operator has
So
higher
I want to
precedence than
increase the
the
size
division
of these
operator.
points.
So therefore,
So I go to the
9
point
exponential 1 is
uh,
computed first,
line,
which
and
gives
I
the
write inside the
result as
bracket
9,
size
and then divided by
equal
2
to
will give us
4.
the result as 4.5.
So I want it to be
But
each
suppose
point
if
to
we
be
use
4
9
times this size that is
exponential
here.
operator, and then
If I
use
click Control
brackets,
Enter at this
and
point,
inside
you can
brackets,
see
we have
the points
1
have increased in
divided by
size.
2 will give
Now,
us the result
very
as
good.
3.
Now I want the line
This is
to
because
look
parenthesis in the
not to be
expression
black. I want it
has
to be
got
another
higher
color.
precedence than
So I
any
can
other
click
operator.
color
So therefore,
equal
since
to
1 divided by
inverted
2
commas.
is
Let's
within
use
parentheses, we
green,
have the result as 0.5,
and I
which
click
is
Control
applied as
Enter.
exponential.
You can see it has
to 9,
changed the line
and
color
we get
to
the
green.
result as 3.
Although this green
In
doesn't
this
doesn't
video,
look
we have
very
covered arithmetic
presentable. So let me
operators
say
such as addition,
blue.
subtraction,
Control
multiplication,
Enter.
division,
You see it has
exponential.
changed to blue.
There are other special
So
operators
I just
in
added
R
these components
which
just to
can be used to
beautify
perform arithmetic
the
operations,
graph. If
such
not, it
as
doesn't change
integer
the
division.
integrity of the graph. It
and
just
modulus.
adds some aesthetics
The special
to it.
operators will
So,
always use percentage symbol.
Having done this,
Let us try to
you
look
can
at how
now
modulus
begin to
operator
appreciate what I
works.
said about
Let us
the
have a number
3 main
modulus
components of
4.
the
This
grammar of
gives the result
graphics:
as 2.
the data,
Modulus
the
operator
mapping,
will return
and the geometry.
remainder of the division.
So once you can get
So
these
when we
3
divide
basic
14
steps
by 4,
into your
we
coding,
get the remainder
you can draw
as 2.
whatever graph that you
We
want to
can
draw.
also have floating point
So,
numbers for modulus
Let's
operation.
use another
For example, 14.75
another data
modulus
set
4
and
will
do some
give the
work.
result as 2.75. Even
So
the
I've
second
already put
operand
in
of
some
the
code
modulus operator
here.
can have floating point number.
Bada
For
boom, bada
example,
boom.
we can have 10
Mm,
modulus 3.5.
Okay, so
which
we're going to
gives the
use
result
a data
as
set called
3.
CO2.
Let us now look at the
I
other
already
special
have it here.
operator, that is
It's
an
also
integer
accessible to
division.
you on your tidyverse
Let us
environment. Once you
apply
just
an
click
operation of
data,
dividing 8 by
it shows
3.
you all the data.
So
Then
we have 8
if you click
divided
view,
by 3.
and that's
The
the name of the
result
data
is
set, you can see
2.66.
that data. So this
Now
is the
suppose if we apply
CO2
integer
data set.
division,
It
that
has
is 8
1, 2, 3,
integer
4, 5
division
variables.
3,
And then
we get
if I
the
look
result
at this
as
place,
2.
it shows me that it has
The integer division
84
always
entries.
returns
That's
the
84
integer part of the normal
observations.
division. For example,
So
when we have 8 divided by 3, we
let's
have
go
the
to
result
our
as
code.
2.66. And when we have 8
So now,
integer division 3,
okay, there's something I
we
wanted to
get
show
the
you
result
first before we
as
do this.
only the integer part, that is 2. Let us now
Now,
look at what happens
this
when we have
same
negative
plot that
numbers
we've
in
done
integer division. For
here
example,
to arrive at
minus
this
8
graph in
integer
our plot
division
here,
3.
we can modify it
get
to
the
say, since
result
we are
as
working
minus
in
3.
the tidyverse environment,
This is because when we apply
we can say
minus 8 normal
we won't start with
division 3,
ggplot, we start
we
with
get
the
result as
data set
minus
BOD,
2.66.
and
Integer
then
division will always return
pipe
the
operator,
floor value. So therefore,
and then we'll press
the
enter,
floor of minus
and then
2.66
ggplot.
is minus 3. We will have the same
So
result if
since
we
we've
perform
already
8
mentioned at the
integer
beginning
division
the
minus
data
3.
set, we don't need to tell R again here
Therefore, always
which
remember
data
that
set. R
when
already
integer
knows
division
what
is
data set we're
performed,
working on.
the result will be
So we don't
floor
need to
of
write
normal
here
division,
data
whether the operands
equal to,
are positive or
because
negative.
R already, we've already told R
We
in
can
the first
also
line
perform
here
arithmetic
that we're
operations
all okay.
on
No,
Boolean
before
values. For
before
example,
this, let me do
we
something.
can have true plus true. We get the
So
result
with this same,
as 2.
let's say GG
In the
plus.
same way, if we have false plus
Now,
true,
we said the first thing to do
we
is
get
tell
the
our
result as 1.
data set, right?
This is because
And
true
write
can be
data equal
coerced
to. But
to have a
since
value
R
1,
assumes that the first thing
and
is
false
data,
can be
we don't
coerced to
actually
have
need to
value
write
0.
data
So
equal
therefore,
to.
when
We
we
can just
apply
write the data
true plus true, we
BOD
are in turn performing the operation
instead of writing
1
data,
plus
because
1,
R
which
assumes that the
gives
first
the result
component
as 2.
is the
In the
data
same
set. So we
way,
can just
when
write
we
BOD,
perform false plus true,
comma,
we are
and
performing
then we
the
move to the
operation
next
0 plus
stage,
1,
which is the
which gives
mapping.
the result as 1.
R knows that the second thing that's coming
Please
after
remember
data
that
set
we
is
cannot
mapping.
apply
So we
arithmetic
don't need to tell
operators
R
on
mapping
strings.
equal to.
For
You can just
example,
go ahead
we
and just
cannot
say
have in
aesthetics.
single quotes hello plus R.
So we've
This will
removed
give us an error.
this data equal
In the
to,
same way,
and we've
we
removed
cannot
this
have hello
mapping equal to,
plus
because R
X.
assumes
This
that
will also
those are
give
the
us
things that
an
are coming.
error.
So
In this
we
video,
do
we will
aesthetics
cover variables
X
in R.
equal
We can
to
use variables to
time,
store values. Variable is a
and
name that
Y
is associated
equal
with a value.
to
A
demand,
variable can be assigned different values
and
during
then
a program execution.
plus
Hence, it is
the
called a
same thing
variable.
here. Okay,
In
let's
this
just write,
case,
let
we
me
assign
just write
a value
it's
10 to the
geom
variable myvar using the
points
assignment operator. That is, in this case, it is equal to sign.
SU
We
size
can then use the value somewhere
equal
else in the code by typing the exact name
to
of the variable.
7.
We can
Let's make
assign
it
a
very
new
big,
value to
and
myvar
then
using the
plus
assignment operator. We assign a value
geom
20.
line,
The variable now has a value 20
and
stored
then
in the memory. The
color
old value of the variable
equal
is
to,
replaced by the new one.
let's use
We can also assign one variable to another variable.
what color do we
It's
use
a good
now?
practice to
Orange.
have useful or meaningful variable names.
So
The
if we
variable
click
names in
Control
R can
Enter
be
here,
alphanumeric and can have underscore as
you
well
can
as star.
see
Variable names always
we have a
to
bigger
start
size
with
of points.
alphabets.
Ah, my chief, my
Excessive
chief.
names cannot be used, such as
Ba abun da ya dame ka.
percentage, hash, at, etc. In R, variables have to be assigned values at the time
Okay.
of declaration.
So we can see
Before we move
the
further,
points are 7
we will
times
discuss
bigger,
more about declaration of variables
and then
in
the line is
programming
orange.
languages. Programming languages are
So
characterized as
that's
statically
it.
typed and dynamically
Then
typed. In statically
moving
typed
further, like I
languages,
said,
type
instead
data
of
has be
having to
explicitly
write the
defined,
data set inside
such as
here,
in C, C++, and
we
Java.
can just tell
For
R
example,
at beforehand
in my
that
var
look,
equals
we're working
N,
in the
where
BOD
my
data
var
sets
is a
and then
variable
use our pipe
declared
operator
by explicitly
and then
using
ggplot.
int data type. And then
So
the value of
because
n
we've
is assigned.
defined what data we
Whereas
are
in
doing
dynamically typed languages,
initially,
the
we don't
variable is not
we don't
defined
have
using
to
type.
tell
Instead,
R
the type
again
of
what data
is
it is. We
determined
can just
at
go straight to
runtime.
the next
For
one, which is the
example,
mapping.
my var
So we can just say
where my var is
aesthetics
defined without the type of data.
and
When
we do the
during
same thing,
execution, the
X
value 10
equal
is assigned.
to,
Its type is
so the same
determined
thing we
only
have
of
here.
integer.
You can just
R is a dynamically typed language.
copy this
Therefore, we will not be declaring variables
and
by
place
its type.
here.
In R, everything is treated as an object. Let us consider X
And then
equal to 10.
we click Control
In
Enter,
R,
and it
X
still
is
gives
treated
us
as an object
this,
as well as it can be
this graph.
simply called as a
So
variable.
I've just been able
Now
to,
let us look at few R functions. We
I've
have
just
a
been able
variable
to
X, which
lead
is
us
assigned
from
a value 10.
the
We
part
can
where
apply
you
type
can
of
you
function on
for you to
variable X.
understand what we're
The
doing,
type function
and then
returns
moving
the
further.
type of
So
the object.
we don't have to
In
start
this
writing
case,
all
it is
those
double. R
X
provides
equal
a
to.
function known as
Now
mode,
another way is
which
again,
returns the mode of the
if you look at
object.
here, we
In
said
this case,
X
it will
equal
be
to
numeric. We
in
can
this
also
place.
use storage.mode, which
So we
returns
don't
the
have to
way
write
the
X
object
equal
is
to, we can
stored in
just
the memory.
write
In
time,
this case, it will be double.
because
we can also use a class function.
R
which returns
assumes
the
that the
class of
first
the
thing
object.
that it sees is
Let us
the
define
X
a variable known as age. If
axis.
we execute
What will
the
be on the X
statement
axis,
using
which
the
is
runtime,
time.
we get an error.
Also here, we don't
This
need
is
to write
because we
Y
have
equal
created
to.
an object
R assumes that the
variable
second
age,
thing it will see
but
is
have
the
not
Y
assigned a
axis,
value.
which is demand.
Let us assign a value
So we can just
using
write
the assignment operator.
aesthetics
Now,
in
when we
brackets
execute
and
the
then
statement, we do
time,
not have any
comma,
error.
demand.
We can also use alphanumeric
Did you follow this last
variable
part?
names. For example, I can have marks1 and assign the value as 10. I can also use
Did you follow this
underscore
last part?
in variables. For example, let us have subject
Awesome, awesome.
underscore
So you can
Java
see we've
and assign
shortened,
the value, let's say 20.
we've shortened
But I cannot
our
use special symbols
coding
such as, for
from
example,
this
I
one
cannot have dollar subject
where we had
assign the
data
value
equal
as
to
50.
BOD,
This
mapping
will give
equal
us
to
an error.
aesthetics,
In the
bracket
same way,
X equal to time and all
variable
that.
cannot
We've
start
shortened
with a
it
number.
to
For example, we cannot
this
have
one now
numerical 3 and subject. This will also give us an error.
because
So always remember
R
that variable names can
makes
be alphanumeric
assumptions.
with the special
If
characters as
here we've
underscore
already told
and
it what
dot,
data
but
set to
it
use.
cannot contain
So
any other
ggplot,
special
no need to write
character,
data equal
as
to,
well
we've
as
already
the
told it
variable
in the
names
beginning.
cannot start with a
And
number.
then no need to
Let
write
us now
X
look at
equal
various
to,
R functions
because
that
it
are
assumes that the
available to
first
find
thing
the
is the X axis,
characteristics
which
of
is
a variable.
time.
Let
No
us
need to
have
write
a
Y
variable
equal
X
to, it assumes
and
that the
assign
second
the
thing is the
value
Y
10.
axis, which is equal to demand.
We will use type
So
of function
that's the,
and pass the argument as
okay,
X.
so having done that,
When we execute these statements, we will get the
let's move
result
ahead.
as double, which is the type
Okay,
of
so next now
variable
we're going to be
X.
working
We
on
can
a
also
data
use
set
a
called
mode function.
CO2.
This will give us the result
And I've shown
as
you
numeric,
it
that
has
is the mode of
5
variable
variables
X.
and 84
We can also use storage
84
dot mode
observations.
function, which
So we're just
also
going to
will
use this
give us
to
the
do some
result
work.
as double. And
So
finally,
now
we can use class as the function to
the
find
code
the
for
class
this.
of variable X,
Okay, so
which is
let
numeric.
me run this
Now,
code,
if we use
everything I've
floating
done
point
here, so that you
number
can look
such
at
as
the graphics and then we
10.75
can
and then
look at
find
the
the
coding
class
from
of
beginning
X,
to end.
it will again
So
be
if I
numeric.
run
So whether
Control
you are
Enter
using
on this,
integers or whether you are using floating point numbers, the class
so
of
this
the
is what it
object
gives me. This
or
is what
variable
the graph
will
it gives me,
always be numeric.
right?
Suppose during execution,
Okay,
X is assigned with a different value, that is, let's say hello, which is
a
a string.
background teaching.
We will
Okay,
also have a statement to
okay,
find
sorry
the
about
class
that.
of X.
Okay, so fine. So this is the
We will
graph
execute
that
from
this
the first
code
line. At this point,
has
the
given
class
me.
of X is numeric.
So we will run
And
through
on
the
line
code
3,
so that we
we
can
are
appreciate
assigning a string
this
to variable
graphical
X.
representation.
And now the class of X is character.
Okay, so first of all, what
Therefore, during
we said we told
execution,
R is
the type of variable
we're working
may
on the
change
CO2
depending
database,
upon the value
and then we
which is
pipe
assigned.
that into ggplot.
Suppose if we have
So
a
CO2
Boolean
pipe
values,
operator, and then we'll go to the next
that
line,
is X is assigned a
ggplot,
value true, then
right?
the class of X
And
will be
then we don't need to
logical.
write data equal to
Variables
again.
can also
We already
be
have the
used in
data up here.
expressions,
And then we
which
don't need
is
to
a
write
combination of
mapping
symbols
equal
that
to,
evaluates
just
to a value.
write the
The
aesthetics
expression consists of
AES,
combination
and then
of
brackets.
operators and
We
operands.
want treatments
In
to
this
be
case,
on
we
the
have A and B
x-axis,
as two variables,
and then we want
which
uptake
is
to be on
assigned the
the
value 10 and
y-axis,
20
right?
respectively. Let us have an
Good.
expression A plus
So
B.
as we've
Here,
after done that,
A and
we
B
close
are
the bracket and
operands,
put
and
in our
plus
plus
is
sign.
the operator.
Now, if
We
you
can
notice, I
store
just
the
want
result of the
to mention
expression.
something here before we move
In
ahead.
this
If you
case, the
notice
result
here,
of A plus
there are
B can be
two
stored in
bracket
variable
signs
res.
here.
Res variable
And
now
that's
holds
because
the result of the
from the
expression
beginning,
A
we
plus
said
B, which is
ggplot, we
30.
open the bracket,
The R language
we
has
put our
certain
aesthetics, we
predefined
open
words
another
known
bracket.
as keywords.
So we've
Keywords
opened
are
two
reserved
brackets.
words in R.
Definitely we'll have to
Keywords
close two
are
brackets.
identifiers that have
You
predefined
understand?
meaning
Good.
in a
So
programming
put in our
language.
plus sign,
Keywords
and then you go to the
define the
next line,
syntax
which
and
is
structure
we want
in
to
R
do a
language.
box plot.
Therefore, keywords cannot
So
be
it's
used as
geom
variables
underscore
or
box plot.
identifiers, such as function name or
Now,
class name.
if I
Here is a list of
remove,
keywords
let
which
me
have
break
predefined
down
meaning
this
in R.
data.
As of now, R has
As
22 keywords.
Put in
All
ash,
keywords in R
here,
are case sensitive.
so
Let us pick a
that
keyword that
we
is
can
break and
understand
try
it
to use the
one by
keyword as
one.
a variable.
Blah, blah,
For
blah, blah,
example, I will
blah.
define
Okay,
break and assign a value
so
10.
assuming I stopped
When
here,
I execute the statement,
ggplot,
I will
aesthetics,
get an error
treatment,
because
x-axis,
keywords cannot be
uptake,
used as
y-axis,
identifiers.
and then geom box plot.
In this video,
And
we
then
will
let me
talk
remove
about data
this
types in R
color
programming
blue thing.
language. There are several basic R
Okay,
data
let's
types
assume
that
I
are
just
frequently
click
used in
Control
R
Enter
programming
here.
language. We will try to understand them better by directly
Now you can see what it
experimenting with
did
the
for
R
me.
code.
Now
In
we
the
have
R programming
treatment
language,
on the
when the variable
x-axis
is created, it is considered as a
and then
vector
uptake
having
on
only
the
one element,
y-axis.
that is vector
Treatment has
argument 1.
two different
We will
values
defer the
in it,
discussion of concept
non-chilled
of vectors
and
until
chilled.
later tutorials.
So that's why you have two different
The most
box
commonly used
plots
data
in
type
this
in R
place.
programming language is a numeric.
So, and then this is
The
the
numeric
uptake.
data type is a default
So this
computational
is
data
what
type.
it gives us when we
Let us
just
create a
run
variable
this
X,
initial
and using the
3
assignment
lines of
operator, let us
code.
assign the value
So
as
data set,
10.25.
pipe operator,
In this
then
statement, X is
ggplot.
declared as a
We're
variable
asking
of
R
type
to put
numeric.
treatment on
In
the
the next statement,
x-axis,
let us display
uptake
the
on the
value of
y-axis.
X.
Treatment is a categorical
To find the
variable.
data type of
Uptake
any
is a
variable,
numerical
we can
variable.
use the class function.
So you can
The
see
class function takes in the
it's
argument, which is the
box
variable.
plot
In
that we
this
use
case, it
to.
is X.
So
When
a
we
box
execute
plot
these statements,
usually
you can
talks
find
about
that first
numerical
statement has
variables
created a variable
because
X.
it gives you the
The second
maximum, the
statement has
minimum
displayed
value,
value
the
stored in the
25th
variable
percentile,
X.
the
And
median
the third
value,
statement
70th
uses the class
percentile,
function,
and the
which
maximum.
returns the
So a
data
box
type
plot
of
usually talks about
variable
numerical
X.
values.
In this
A
case, you can
categorical
find that we have the
variable
result as numeric.
is used to disaggregate the
Let
data.
us assign an
So like
integer
here
value
we
to
have
variable
two different
X.
box
That is, in
plots.
this case, it is 10.
This categorical variable
When we
is used to
execute these
disaggregate
statements,
between
you can find that the
non-chill
type of
treatment
variable
and
X is
chill
still numeric.
treatment. So
We can
the
use a function
categorical
s.integer
variables usually
and pass
disaggregate
the
the
variable
data
X.
into the
When
different
we
levels,
execute the statement, you
while
can find
the
that we get the
numerical
result as
variables
false.
is what
This is
actually
because
drives the
even
data.
though we have assigned an integer
So
value to variable
we've
X,
done this.
it is still considered as a numeric
Okay,
data type.
so the next line of
In
code,
order
if
to
you see
create an
here,
integer
says
variable in
geom
our programming
point.
language, we
Now,
need to invoke integer
let me
function.
remove the hashtag
For
on it
example,
so
we
that
can
we can
use
run it.
as.integer
Fixing our plus sign here.
and
Let's
then
remove
pass
the
the value
plus
as
sign
10.
in this one.
When we execute
So
these statements,
this
you
is
can find
geom
that the
point.
class function returns
Alpha
a
equal
variable
to
as
0.5.
It's like this. Hello? It's like this. It's sound coming from
And there you
another
and L suffix to the value.
Maybe you should type it in the chat because I can't hear you.
I
Maybe
think
you should type it in the chat because I can't hear you.
okay.
You can also take floating point values or decimal values. But this floating point value, that is in this case 10.25, will be converted to an integer. And when we execute these statements, you can find that we have the value stored for variable X as 10. And the data type, that is the class of variable X, is integer, as well as isInteger function will return value as true. We can also pass decimal numbers as characters as an argument to the integer function. For example, in this case, let us use 5.75 within single quotes.
Okay, sorry.
When we execute these statements, you can find that we have the result
let's remove that
as value 5, which is stored in variable X.
It was my fault.
And the data type of variable X will be.
Can you still hear it? Oh, fine. I'm sorry. Okay. Fine. Let's go back to our RStudio. Okay. So this next line of code we want to run, this one, I'm just going to explain it. So first of all, we said geom_point. So it's just going to give us points. Now, however, we want to characterize those points. First of all, let me put this. This is supposed to be behind, so I can even understand what I mean. Oh, sorry. I copied out something from here. Okay, I forgot to run this color blue that was in. So let's assume the box plot. We say color blue on it. And run Control Enter. So you can see the background of the box plot has been changed to color blue. Just because we put color equal to blue within the geom box plots code, right? Okay. So we're going to run the third code. And the third code says geom point. So let me remove these things here and then just run it so you can appreciate. So if I run geom point, you can see that that line that was here, it has changed it to points now in this place. Now, let me put in some things in here. I remove this one. Okay, so within those points, the geom point, I want the color. Now, there's a difference here now of this color and this color in this first place. This color is blue, but here I want to use a variable in the data set to represent color within this box plot. If you look at the data set here, there is a column that is called plants. There's a variable called plants. Good. So we want to use that plant to categorize these points in this place. Let me remove this one. Size. So if I click Control Enter here, you can see. Let me enlarge that so we can look at it very well and the plots. Okay, so you can see this is the plan. This is a legend of the different categories in the plant variable. And it has attributed those different categories by assigning them different colors. Now, R has represented these points based on this plant variable here. You can see these points have different colors. And that's because we have categorized them by these plants over here. You can see both places. Do you appreciate that? Okay. So now we're going to do another addition. So I've added size. Size is another variable in the, sorry, no, I mean not size. Concentration, CONC, is another variable in this CO2 database. You can see it here. Good. So we want to add concentration within this plot to also be used as a form of representation in this plot that we have here. So let's go back to our coding, and this is the plot. So size, concentration. We're still talking about geom points. So all these things we're working on is on the points, on those points. So we say size equals to concentration. If I run this code, can you see the sizes of the points have been disaggregated? Good. Let me increase the distance so you can see it. So you can, let me show you the legend first. So this is the legend of the concentration. It has 250, 500, 750, and 1000. And that is what categorizes the sizes. So with that, these points within this plot have been categorized based on the size, on the concentration, and it's the sizes